My name's John Wise. I'm part of our worldwide Power sales team. I've been working on the HANA on Power rollout for the last 3 years. And I'm going to take you through kind of where we have come, where we're going, kind of what the key value propositions are that separate us from the 11 Intel vendors that are selling HANA systems. And happy to take any questions. It's a small crowd, so we can go through it pretty easily. We're up over 1,250 customers. Been very, very rapid acceleration, really across all industries. I'm going to show you a little bit of that. From the very largest corporation in the world to many, many small corporations just starting their S4 journey. Basically all of these on SUSE. So we've been very tightly connected with SUSE since the beginning, right? You can see the one thing that's been very surprising to us is, traditionally most power business has been customers buying for their on-premise, but what we've seen is a huge number of MSPs kind of filling that gap between the HANA Enterprise Cloud and on-premise, and we've got some very, very large ones. Matter of fact, the cloud partner of the year this year, Sador, is running all on Power. So basically across all of the geographies, various MSPs have picked up Power and are using it to be able to deliver to their customers much greater flexibility in the way that they're provisioning and delivering HANA systems to their customers. You see my pin. Power was named the Infrastructure Partner of the Year this year for SAP. That is a reflection of many of the things that you saw on that last slide. IBM has a really big event every year. It's close to the size of this. It held in March. We had one of the customers that is fairly representative of what we hear from various customers, talking about how their cost of ownership has gone down 50% since moving from Intel to Power. About 20 to 25% of the customers that we've gotten so far had tried on Intel and have given up. We hear consistently for one of three reasons. The number one reason, and I'm going to talk about kind of our value proposition, and I'll get into kind of why you're seeing customers move. But these are the public references. So there are videos out there on all of these. They cover a lot of industries. There's many, many more customers. As I said, there's over 1,250 at the end of last quarter. So basically, whatever industry you are, whatever size you are, we probably already have a customer much like you. Maybe not quite as large as there's some unique ones in the audience, but really three basic value propositions that have made a big difference in how we're able to deliver HANA systems. The first of those really is flexibility without compromise. And basically what it means is that you can build any size system that you need. You can carve that system into as many individual systems from a production standpoint as you need. So, if you have a 1.3 terabyte database, you can carve out a 1.3 terabyte partition. It's fully supported by SAP. You can do other things with the rest of the system without any constraints, right? So you can have up to 8 production systems on a single system. You can have as many development systems, as many app servers, in addition to those as you need. We've sold Power for many years based on the performance, right? Our cores do between 2 and 3 times what an Intel core does. So in most cases, what that's meant is a lowering of your licensing costs, because things like Oracle are sold based on cores, and because HANA's priced on the size of your database. It doesn't make that big a difference in the price that you're paying for HANA. But what we are seeing is customers able to meet SLAs that they were not able to meet on the Intel systems. I've got an example of that I'll show you. And really, the number one reason that the customers have been leaving the Intel systems is the reliability of the memory subsystems. When you're talking about an in-memory database, the reliability of your memory subsystem makes a huge difference. We basically build all of our systems where we spread the data across multiple DIMMs. We protect that with ECC, so basically parity, and then we put spare memory DIMMs on every memory card, and we've got something called a service processor in every system that is doing constant soft scrubbing of all of your memory. If it starts to see any failures at all, it's going to spare out those DIMMs. So basically, our systems are staying up without compromise. You won't see any papers, white papers from us like you will from the Intel systems, basically telling you to reboot your system every 2 weeks. That's just not the way power systems are built, right? We have systems that have been running for many, many years without being rebooted. There's a really good story about one of the power systems being drywalled into a closet. Construction crew came in. They did a bunch of drywall. It was about a year and a half later. The people needed to do something to the system, and they went looking for the system and they couldn't find it. They actually had to trace the wires, figure out that there's a system behind this wall, and they had to break down the wall, right? So you're not going to see us recommending you reboot the way that the Intel systems are being done. I talked about performance. This is an example of what's one of our public examples. They were running on Intel. They were not meeting their day-end SLAs, right? So all of you know that SAP is very strict on the way they have you size systems, right? They use these memory to core. So both of these systems were sized using the exact same SAP sizing. So you would anticipate that their performance would have been about the same. We're actually able to reduce their day-in processing by a factor of 5. This is a big retail company. They're able to put trucks on the street earlier in the afternoon than they were able to meet their store demands for the next day. I mean, this is making a big difference in the way that this company is actually able to run their business just based on moving to power. This is another example where we ran a head-to-head benchmark against one of the big Intel vendors, and you can see we're doing 250 times the transactions per second that they were doing. Once again, based on SAP sizings, the systems are supposed to run at the same performance, and clearly they don't. I talked about some of these things, right? The virtualization capabilities, the ability to set up partitions at any size you need. So when you see SAP sizings, they'll say, oh, you have a 240 gigabyte database, so you should buy a 512 gig system. So we said, no, you should carve out 240 gig, the amount that you need for that system. Why would you put twice the amount of capacity into something that you need, right? You're paying for things that you're not using. We'll guarantee our systems will run up to 85% utilization without any performance degradation. You should use that, right? That makes a huge difference in the way that customers are able to look at their TCOs. Those MSPs that I was talking about earlier, all of the ones that will talk to us will basically say that they're able to deliver twice the value to their customers using power that they were able to on Intel. And so it's allowing them to be much more flexible in what they're giving their customers. It's allowing them to give their customers better prices. And they're winning a lot of business because of that flexibility. And it's really based on all of the virtualization things that are built into every power system. This is in the firmware, it's in the hardware, right? It's not an add-on. So we're able to meet all of the KPIs, the key KPIs that SAP requires us to do with this. We deliver things like elastic capacity on demand. You buy a system that will have dark cores and dark memory. As you grow, you can pay to turn those on. You can use things like you can turn them on by the day, or you can turn them on permanently. All of our systems are TDI. We do not deliver any appliances. This is just some of the key characteristic differences between power systems and Intel systems, and this is what's allowing us to do the performance, right? The systems are built to handle, large memory environments, large I/O environments. I mean, some of the things like rebuild of HANA environments, with some of the IBM flash subsystems, storage subsystems, we're measuring rebuild times at about 2 to 2.5 minutes per terabyte. You see that's significantly faster than you're able to do on an Intel system. So we've just come out with our first of the next generation systems. They're Power 9 systems. We've measured chip to chip for various types of workload, and you'll see that for most types of workload we're going to be seeing between 1.6 and 2.2 times the amount per chip that you're able to do, the amount per core that you're able to do. The new low-end systems are out now, so systems up to 4 terabytes. Midsummer we'll be seeing systems up to 16 terabytes, and later in the year you'll be seeing systems up to 64 terabytes. So I talked about reliability, right? This is the number one reason that we're seeing customers give up on the Intel systems. I was just in a meeting with a customer that's taking their systems down every weekend to do preventative replacement of memory DIMMs. I mean, it's when you have really, really big systems, if you allow them to take a hard crash, it can cause really bad things to happen. So we build our systems. I've talked a lot about memory, but it's in the CPUs. We have basically where if you have a CPU take a hiccup, the service processor will try that CPU again for the same instruction. If it fails, it will send it to a different CPU. You're not seeing the blue screen of death that you see on the Intel systems. I talked about, so this is kind of a view of the progression that we've made. I mean, unlike everybody else who's delivering systems for HANA, we control our own destiny as far as processors, right? The other 11 guys are all very dependent upon what Intel is delivering for them. And I mean, you can see in some very visible examples recently where, the biggest competitor in this market, their flagship product didn't support Skylake, right? So, very, very, it's never going to happen in IBM systems. This talks about the systems, shows the systems that I mentioned briefly, right? These are already out, came out early first quarter, and we're going to have the mid-range up to 16 terabytes and the high end up to 64 terabytes before the end of the year. With that, are there any questions?
Are y'all done, John?
I am all done.
All right, let's give a big hand for John. If you guys have questions, maybe you can hang out a minute and they can come up afterward. All right.